Fella asked me a question with respect to his SX4, 2008 model year, I believe it is. He had a question with respect to his electronic power steering system, the EPS, not to be confused with the ESP. I'm quite familiar with the electronic stability program. However, I have no exposure to the electronic power steering system on the SX4s for the simple reason Canadian cars, as far as I understand, never came with the electronic power steering, just the old school hydraulic pump type power steering pump and hydraulic assist, if you will. So it's a hydro-mechanical system on Canadian models as opposed to an electromechanical system on the electronic power steering variants. He actually had a scenario transpire where he crossed some relatively deep water, I take it, and now he has issue with the system. So that will be obviously a significant clue to what the issue likely is with the system. So let's just consider the architecture here in a simplified form. We don't need to look at all the components. Let's just consider the basics. So in just a basic mechanical system, of course, we have the steering wheel acting on the column through the shaft and U-joints, and down to your traditional steering gear, obviously with the output going through the inner and outer tie rods, steering your wheels left and right at the steering knuckle. So that would be the mechanical end of things. That's on virtually all cars and still is, of course. But the electronic power steering assist is actually clever in the sense that what they've done is they've looked at that system and they've said, well, if we look at the demand which is imposed on the system by simply looking at, obviously as you're turning the wheel, you're imposing a torque on the system with respect to the input. Let's put a couple of torque sensors down the system, a primary and a secondary, so for the sake of redundancy and monitoring, fault monitoring purposes, there's two of course. And we'll use a control module to monitor that. And if we monitor that, if we know there's a torque demand left or right on the system, we can actually act on that torque demand simply by actuating a motor, an electric motor, bidirectional. And we can control the direction or rate of displacement by duty cycle controlling it. We'll see that in the manual a wee bit later. We'll see an oscilloscope trace. Now, just context. This fella doesn't have a scan tool. He doesn't pretend to be an expert on this system. He's just wants to know if he can check a few basics. Well, yeah, I think we can do that. We can check a few basics, but we need an understanding of the system in order to put those checks in context, make some sense, right? So just before we leave this drawing here, guys, you can see there's a number of components I've left out of the explanation because you'll see in the schematic here when we get ever increasingly complex as we step through the drawings, interfaces through the CAN bus for the most part, with the body control module, the engine control module that's showing the battery schematically there as well, and also there's diagnostic capacity, of course, which is interestingly through the K line as opposed to the CAN bus when it comes to the power steering system control module. So here's a statement in the manual, guys, that tells you basically the power steering control module will consider the following components with respect to diagnostics, right? So it's not going to look at the entire car. It's only looking at subsystems or components within its system itself, right? And you can see it's the torque sensors, the vehicle speed sensors, the engine speed signal, RPM, the power steering motor itself, I guess the health of that in some way, shape, or form, and the power steering module itself, some self-diagnostic capacity, I guess. Okay, so that little statement there actually is a great help to us for the simple reason we know that this defect transpired when the vehicle crossed some water, a flood of some sort on the road, right? So I think we can pretty much dismiss some things right away. Is it likely to be the power steering control module? Well, that never got flooded, but it's possible something shorted and has taken that out. So we won't dismiss that outright. The power steering motor may have been submerged. The engine speed sensors, typically the crank position sensor, of course. Well, the engine still runs. It's possible, but unlikely. The vehicle speed sensors, wheel speed sensors are typically performing that function. He made no mention of the fact that there was any issue with the ABS system. If there was a wheel speed sensing issue, there would be an ABS fault. Undoubtedly, there isn't. So I think we can dismiss that one, and the torque sensors. So the two that I think are the likely suspects are the torque sensors and the power steering motor itself. For the simple reason they're in this location, the ground clearance is minimal. Those are the likely culprits, I think, in this scenario. So just in the interest of clarity here, guys, this is of course the dashboard we're looking at, and if I understand his question correctly, this is the fault annunciator that's actually on the panel. SX4 owners in Canada, probably the States, I would think, are probably completely unfamiliar with this icon, but it is there. But it is not lit on the test when you actually cycle the ignition key, for the simple reason the system's not installed on our cars. But if you look at the dash, you will find that icon, although it's unlit certainly in Canadian models, for the simple reason the system doesn't exist. But this is the fault, so we know that the power steering module has sensed an issue with the system and has said there is a fault. The fault is obvious because there's a high drag or a high load on the steering wheel itself when he tries to steer the vehicle. So I'm just trying to step up this drawing in complexity so we don't blow anybody away with the schematic we'll look at the end, because there's quite a lot of detail. So we can see we have the actual power coming through the from the distribution module, which is under the hood itself. Fuse box, if you will, the main fuse box, the ignition key, a couple other fuses here. For the fellow who actually is asking this question, you can maybe freeze your video and scrutinize this detail. I'm not going to do that in the interest of trying to move the video along, but you certainly can, as I would if the shoe was on the other foot. So a couple of fuses in the system, obviously makes sense to check those. Two power supplies coming in item 5, which is the power steering control module itself. Check both of those. That would be relevant, obviously. We have the power steering module, and here is the torque sensors. You can see it's 2 channels, a couple of operational amplifiers. Looking at the input, you can see here that the inputs are actually shown. I don't know, I know you guys can't see it on your drawing here, but they're not shown as variable resistors. They're actually shown as variable inductors. So that's kind of interesting. How they're actually sensing the torque, I don't know, but it doesn't really matter. But we can take it for granted that there is load sensing or torque sensing, load in a rotational axis, being done on 2 separate channels, a main and a sub, as Suzuki calls it, primary, secondary, channel 1, channel 2, AB, whatever you want to call it, 2 separate channels. Looking at that torque input, there is a steering input. You are commanding the wheels to be displaced either left or right. You're not at your desired steering angle. That's not necessarily a center line, right? It could be once you've attained your the correct displacement and you're going through a constant curve, that would actually stop the motor from driving as well, right? Although we'll look at the drive and we'll see it. It's a wee bit interesting because there is actually drive on both sides of the motor in the interest of stability. So in any case, I digress. We have torque sensing, the module itself, and the actual input. And so we'll take a look at, so this input comes in to the module assesses it. Do we need drive output to the motor? And the motor's not on this drawing. We'll look at another drawing, you see that? Just before I leave this drawing, it's relevant to actually understanding what you're looking at on the car. The E31 connector is this connector here, guys, item C. It's the connector that actually is connected to the torque sensing, the 2-channel torque sensing at the steering gear itself. The other connectors, of course, are at the power steering control module. Okay, so here's the business end of the system, guys, the motor that's actually done at the steering gear. Again, if the torque sensors actually are telling the power steering control module, we require an input from the motor. Obviously, it will be a rate and direction input from the torque sensors, and that will be acted upon via the control module, sending a direction and rate via duty cycle control signal to the motor itself. Yeah, so there'll be a separate connector down at the steering gear. There'll be one for the sensing and another for the and I believe another for the motor itself. If you're looking for quality, you're on the wrong channel. Sorry about that, boys. I didn't realize that the drawing was actually a wee bit skewed there. In any case, this drawing here, again, just in the interest of building towards the complexity of the final drawing, this one's showing some interfacing between the power steering control module itself and some of the other units in the some of the other modules in the car. Here is it's interested in only the front wheel speed, the left and right front wheels. That kind of makes sense since we're talking about steering system. The wheel speed sensors, of course, all of them, not just the front, are feeding their input to the ABS control module, item 9 there. Then via the CAN bus, it actually exchanges information with the engine control module, item 5, and the body control module, item 6. You can see that information is then shared with the power steering module, but there's no CAN bus connection between the two. On the connector E11, pin 11 here, this is actually the serial bus, the K line from a diagnostic standpoint. So there's a serial bus exchanging that information and likely a bunch of other information as well. But just in the interest of building towards the final schematic, so you can have some idea what's on the final schematic with the mind-blowing complexity of the entire drawing coming at you. Another drawing showing actually the data link connector itself. You'll notice that this is actually pin 7. Again, going through the body control module, and it's on the K line that your scan tool, if you had one, that's not the case with this fella, but if you had one, it would be the K line that would be actually interfacing with the power steering module with respect to diagnostics. Okay, so towards the final schematic. So we have a pretty good idea of what's actually going on here now. We realize this is the major bits we're interested in, the module itself. We can see that we have, this looks very, very similar to electronic throttle actuator control circuit. It's a bidirectional chopper circuit. That's what actually applies the polarity and rate done via duty cycle control signals applied to both inputs on the motor, so we can steer either left or right and at what rate we want to steer the vehicle at. And here's the torque sensors. We've seen those. Here's all the basic power supply and grounds to the system, and again some interfacing with some other modules on the car that we've already considered with respect to wheel speed, body control module, and engine control module. There's the annunciator on the dash itself in the event there's a fault, which there is. So I think we're really looking at an issue on the motor. Sorry about the long drawn out explanation, but the bottom line is I think we're looking at an issue with the motor or the torque sensing here. So take a close look at the diagram there. In the event you have a meter, I'm sorry I don't know the fella's name, but in the event you have a meter, you can actually check the inputs. You can see the power supplies that's coming into the torque sensing module, if you will, on the one connector, and the other connector for the motor itself. These are clearly going to be very heavy gauge wires to the motor, because I think there's like serious current going to this, like 30-40 amps of current. So they're clearly going to be pretty serious wires that are going to go, should be easy enough to make the distinction between what's control and what's actuation. You guys have heard me rave about the Suzuki SX manual in the past because it provides us with some fantastic information. These drawings here are going to be a great assistance in helping us understand how this system actually functions. So you can see we have two traces on the scope here, and you can see the conditions and the setup that it's actually using. But what's important to note here is this is the motor output signals. Now that would make you think this is coming back from the motor if you didn't look at the pinout. I've looked at the pinout. This is what's coming out of the power steering control module to the motor. So essentially it's motor input, I think, is maybe a wee bit more helpful in understanding what's going on. This is what's being applied to the motor basically with respect to steering command, right? So, and this shouldn't come as a surprise that this is the scenario for this measurement. Engine is idling and the steering wheel at straight position. So there is no command into the steering system. You're not asking for the wheels to displace. They're basically on the center line of the vehicle, right? So let's continue down here. and we'll look at the second waveform on the left. You can see the input here, guys. You can see that we now have a square wave, which is duty cycle controlled. And the scenario here is the engine is idling, steering wheel is turned to the left or right at a rate of 90 degrees per second. So what this is telling me here, and again, I've never seen this system. I've never put a scope on this system. But what this must be telling me is this duty cycle is going to change. That is to say, the high and the low ratio of the signal is going to change depending on the rate of steering that you put in. You can see here that this is basically going to give us a polarity. Can you see how the two signals are opposing in polarity? But it's the duty cycle that is going to determine the rate. So that is to say, if you steer quicker, the pulse will widen, and then or narrow if you steer slower. I hope that makes some sense to you guys. On the right hand side, it's showing you the measurement conditions. Engine is idling and steering wheel is kept fully turned to the left or right until it stops. So you can see here that we have, you've turned it to the stop. You're still imposing a torque at the stop, and it's trying to drive in the left or right direction. Of course, if you were turn the steering wheel until it stops in the opposite direction, I would expect this signal to actually completely change, toggle positions, if you will, right? The straight line would move down to the channel 2 here, and this condition would move to the upper, although it would likely be an opposite polarity, but the duty cycle would be the same. I know this is probably getting maybe a wee bit too complex, but if you think it through, it actually all makes sense. Yeah, so here actually I should have read a wee bit further down here. You can see that it actually shows us the upper state here in this drawing in reference waveform 2, guys. The steering wheel is being turned to the left at 90 degrees per second. That's the rate here. And then it's 90 degrees per second to the right. And you can see that it actually toggles completely. So the duty cycle will be higher in the direction that you're actually turning. I hope that makes some sense. Without actually seeing it on a car and being able to demonstrate it, and just working from the static drawings is maybe a wee bit difficult to wrap your head around. I understand that. And here you go on the exactly. I didn't see this. I should have scrolled down. And I'm not just saying that, guys. This is the first time I've seen this drawing. You can see here that our waveforms have actually completely changed from a polarity standpoint. And of course, because you're at the limits, there is no input on the other channel. So what I would look at is, again, the power supply. Maybe something, a fuse that we had seen on the previous drawing has actually gone. Something is likely waterlogged. It's possible if there's been water intrusion into the motor or the sensors, they're actually fried now. But I would be looking at the torque sensor, the torque sensing, and the motor control itself. Perhaps lifting the battery ground and just resetting the system once it all dries out will actually be of some assistance. But there is a notation in the drawing here that mentions that if a fault occurs, a reset will have to be done before the normal operation of the system is done. Of course, that's some safety provision to make sure that a technician has actually assessed the system as fit for service and reset the system, of course. So I'll just mention before I close here, guys, that on some systems, I know there is like a plastic coupler of sorts somewhere in the drive system here. So long as everything is functional, everything stays in synchronicity with respect to the mechanical input and the electronic input. Everything stays in sync. In the event there's a failure, there might be a plastic breakout mechanism of sorts that needs to be replaced in the event of a failure when the system actually goes out of sync, so that the mechanical system can actually drive the system unimpeded. Anyway, I hope that's of some assistance to the fella who's struggling with it. I know it's just really a look at the architecture and theory of operation, but it might be useful to the fella. It's certainly been useful to me, again, in understanding how it works, even though I don't think I'll ever deal with it. But I certainly will probably deal with it at some point in the future on another vehicle. I guess my SX4 can't be expected to last forever. That's it, boys. Cheers.